Hi everyone, good evening. I'm Christina Daly from the Department of ECE. In this lecture series, we are going to see about the silicon controlled rectifier, that is SCR. So what do you mean by an rectifier? Already we know that rectifier, it is nothing but it converts the alternating current into the direct current. Apart from that, we are going to see the silicon controlled rectifier. So in silicon controlled rectifier, it is a three terminal device where it consists of the anode, cathode, another one will be the gate. So here, while seeing the PN junction diode, it consists of only two things, that is two terminals. One is anode, another one will be the cathode. But in case of this silicon controlled rectifier, we are having three terminals. One is anode, another one is cathode, another one will be the gate. So what is the function of the gate? What is the purpose of the gate in this SCR is it is used for the switching functions in the power circuit. So that is the function of the gate. So the next one, the silicon control rectifier, it is also called as the thyristor. The next one we are going to see about the junctions in the SCR. So we are having three PN junctions in silicon control rectifier, and we are having four layer of P and N type semiconductor. So here in this PN device, we are having three terminals that are taken from the outer p-type layer called anode, and another one layer is called the cathode, and the third from the internal p-type layer is called gate. So here we are having three junctions, that is J1, J2, another one is J3. Both the PN junction has been connected, and that region is said to be J1. Again N type and P type gets connected, that region is termed to be as J2. Again P type and N type has been connected, that is termed to be as the J3, that is junction J3. Along with that we are having the three terminals, that is anode, cathode, another will be the gate. So the gate, it is nothing but it is used to perform the operations. So here we are going to see the SCR working principle. So what are all the three major things that has been used is, one is forward blocking mode, forward conduction mode, another one is the reverse blocking mode. So here we are going to see about the forward blocking mode. So this is a diagram of the forward blocking mode of the silicon control rectifier. Suppose we are going to apply the positive voltage to the anode of the SCR with respect to that of the ground. What happens means the current will be, the gate current will be 0. At the same time, the junction J2 that has been connected to the J2 will not conduct. So this is termed to be as the forward blocking mode of the SCR. The next one we are going to see about the reverse blocking mode. So the reverse blocking mode is nothing but that has been connected with respect to the anode. At the same time, here the junctions J1 and J3 will be reversed by us, and therefore the device will not conduct. So this is the reverse blocking mode of the SCR. So the next one we are going to see about the forward conduction mode. So in this forward conduction mode, an SCR will work in two regions, that is two ways. So here without gate current what happens, and when the gate current is applied what happens. Suppose without gate current, suppose if the anode voltage is increased beyond the certain limit, so that is termed to be as the breakover voltage, that is VBO. At the same time, suppose if the gate current is applied, at the same time the SCR starts conducting, what happens, there will be no gate current is needed to maintain the anode current. So this is termed to be as the forward conduction mode. So this is the VI characteristics of the silicon controlled rectifier. So it is nothing but the relationship between the voltage and the current. So while the condition will be in on state, suppose if there is any drop in the voltage, there will be a breakdown, and again it goes that is termed to be as the avalanche breakdown. So the next one we are going to see what are all the applications of the SCR. So we are having so many application. It has been used in the computer logic circuits, timing circuits, inverters, and the temperature control systems. So these are all the applications of the SCR. So these are all the assessment questions in the SCR. Thank you.